Okay, now we're going to be using multiple steps to solve an equation. So this is still Module 3, and we're talking about solving equations still, which is still section 2.2. And we're going to be using multiple steps. So we originally talked about one-step equations. Now we're going to be using more than one step. So using multiple steps to solve an equation. Okay, so remember, the goal is still to get the variable by itself on one side of the equal sign. So remember, the goal, and we're always talking about when we're solving equations, the goal is still to get the variable by itself on one side of the equal sign, meaning it has a coefficient of 1. On one side of the equal sign. Another thing we say is we call it isolating the variable. Okay. So the first thing we do is we want to isolate, we identify the term that contains the variable, and we want to isolate it. First, identify and isolate the term, right, the whole thing that contains the variable. And then the last thing you do is divide the term by the coefficient. Or you can think of it as multiplying by the reciprocal. By the reciprocal of the coefficient. Okay, so it'll be a little bit clearer, I think, when we start working through some of these problems. Okay, so for example, let's say we are asked to solve negative 5y minus 5 equals 10. Well, the first thing we look for is the term that contains the variable, right? And that's this negative 5y is the term. That's the term containing the variable. Okay? And that, so we want to first get that by itself. So what's with it? Well, we have this minus 5 here. So we treat this as though this is just one block and we need to get rid of everything else on that side. So just like we did before in the one-step equation, we want to get rid of this minus 5, right? We have a minus 5, so what do? We do the opposite and we add 5. And again, what we do to one side of the equal sign, we have to do the other, right? So now this minus 5 plus 5 cancels, and I have negative 5y equals 15, right? Because 10 plus 5 is 15. Well, now this looks just like one of our equations that we were working on in the last section. This reduces down to a one-step, and so the last thing I do is I divide the term by the coefficient. And what's my coefficient? Well, my coefficient is negative 5. So I need to divide both sides by negative 5. and I get y equals -3. Okay, so again, this was my original problem, right? So I added 5 to both sides of the equation to get the term with the variable by itself, right? And then the last thing I do here is I divided by -5, which is the coefficient on both sides, to make the coefficient 1, and I get y equals -3. And I can always check, right? My original equation was -5y minus 5 equals 10. So if I plug in -3 for y, right, I have -5 times -3 minus 5, does that equal 10? So I have -5 times -3 gives me positive 15 minus 5, does that equal 10? And I have 10 equals 10, so sure enough it works. Okay, so let's try another one. We can try solve 4u minus 8 equals 60. Right, so I figure out what's the term that has the variable, and I isolate that one first. So there's my variable, right? I have a 4u. And what am I doing to that 4u? Well, I have minus 8 over here. So I want to get rid of that 8. Again, what I do to one side, I have to do to the other side, so I'm adding 8. And remember, I only have sides when I have my equal sign, right? I'm talking about one side of the equal sign. So I added 8 to both sides. These 8's cancel. I have minus 8 plus 8 gives me 0. So now I'm happy. I have my term with the variable by itself. I get 68. And the last thing I always do is divide by the coefficient, or multiply by its reciprocal, right, on both sides again of the equal sign. So I'm left with u equals 17. And again, I can check. I can always check my answers, right? So my original problem was 4u minus 8 equals 60. So I'll plug in 17 for u. So I'll say 4 times 17 minus 8. Does that equal 60? Well, 4 times 17 is 68. Minus 8, does that equal 60? Sure enough, it does. So we got the right answer. Okay, let's try another one. Here my coefficient is, I'll say solve 2 equals 1/2 a minus 7. Well, don't worry that the variable is on the left side. It doesn't matter if it's on the left or it's on the right. Our goal is still to isolate it, right, or to get the term by itself. So again, I identify the term that has the variable in it. Well, a is my variable. This whole thing is the term, right? It's 1/2 a. So the process is the same. I go and I try to isolate it, or get it by itself. Well, what am I doing to this 1/2 a? I'm taking away 7. So what do I need to do? I need to do the opposite, which is add 7. So I add 7 to both sides of the equal sign. And I get 9 equals, my 7's cancel out on the right-hand side, and I have 1/2 a. Okay, well, here I have a fraction, right, for my coefficient. But that shouldn't bother you. If you're dividing by a fraction, it's the same as multiplying by the reciprocal. right? So what I can do is say, well, this is all multiplication now, right? It's 1/2 times a. So I'm going to take the reciprocal of 1/2, right? 1 over 2, I flip it, that's 2 over 1. If I do that on one side, I have to do that on the other side. My 2 over 1 is just 2, so I get 18 equals. And the thing about multiplying by the reciprocal is, remember, it all goes to 1. So I just have a equals 18. And again, I can check, right? Does 2 equals 1/2 a minus 7? Does 18 satisfy it? So we'll say, does 2 1/2 times 18 minus 7, does 2 equal 9 minus 7? And yes, it does. So we came up with the right answer. Okay, let's try one more. Solve. 10x minus 3 equals 4x minus 2. Okay, well, in this case, I have variable terms on both sides of my equal sign. All right, so now what we need to do is we need to gather, we're just going to decide that we want to move all our variable terms onto one side and all our constant terms on the other side. So now we have variable terms on both sides. All right, so what do? We're going to gather variable terms on one side of the equal sign and constant terms on the other. Okay. Again, if once I'm starting to move across the equal sign, I have to, let's say I want to get all my x terms to the left. Well, that means I want to get rid of this x term here. So this is a positive, so I'm going to take it away by subtracting it. So I'm going to subtract it on this side as well. And I'm left with 6x minus 3. 4x minus 4x goes away. I still have my equal sign, negative 2. Again, this looks like one of the problems that we were just working on, right? So now I have my variable. I only have one term that has that variable, so I'm going to isolate that. And if I'm moving things across the equal sign, I need to do the opposite operation. So I want to get rid of this 3, so I move this 3. I add 3 on both sides of the equal sign. So I have 6x, my 3's go away, equals 1. And remember, the last thing I always do is divide by my coefficient. To get x by itself, I take 6 divided by 6 gives me 1. And then I have to do it to this side as well. Right? So these cancel to go to 1. So x equals 1/6.